Welcome to The Explainer. Today, we're going absolutely all in on the definitive guide to the biology and mechanics of physical fitness. Look, we hear the word fitness thrown around constantly, right? But what does it actually mean when you strip it down to a biological, mechanical, and even psychological level? Today, we're going to unpack the hard science behind human performance. We're taking that dense, textbook physiology and turning it into actionable knowledge you can use to really understand your own body's machinery.
Okay, let's dive into this. Our baseline here is the classic textbook definition of fitness. But notice something absolutely crucial. It doesn't just talk about sports. Physical fitness is this fundamental state of health that dictates everything from crushing a marathon to, simply getting out of bed or having the energy to get through your daily job. It's the whole shebang. Achieved through physical activities, a balanced diet, and proper recovery. In this explainer, we're going to break down exactly how the human body biologically achieves and, more importantly, maintains this exact state of well-being. So here is our visual syllabus for today. First, defining physical fitness. 2, unpacking muscular strength. 3, the science of strength. 4, understanding endurance. 5, training your endurance. And finally, number 6, flexibility and body composition.
All right, jumping right into Section 1, defining fitness and what health and well-being actually look like.
There are 5 core components of health-related physical fitness that you really need to know. We've got muscular strength, endurance, flexibility, body composition, and cardiovascular endurance. Developing these is what actually reduces your risk of heart disease, diabetes, hypertension, and even depression. Now, while we obviously need all 5 of these working together for total wholesome development, our deep dive today is going to predominantly focus on the 2 major engines of human movement, that is, muscular strength and endurance.
Moving right along to Section 2, muscular strength, where we tackle force and resistance.
At its absolute core, muscular strength is directly related to force production. You literally cannot move without it. And force is always exerted against some form of resistance. Now, that resistance comes in 2 very distinct flavors. First, you have internal resistance. This is when your muscles are acting against your own body weight, think running up a steep hill or busting out a set of push-ups. Then, you have external resistance. That's when you're acting against an opponent's body weight, like in a wrestling match, or moving heavy plates in the gym. But in both scenarios, your muscles have to contract to overcome or resist that applied force.
And this brilliantly illustrates exactly what we're talking about. When an athlete uses weight machines or barbells, they're intentionally applying external weight. It's a calculated resistance designed to literally force their muscles to adapt. Designing a resistance training program means strategically manipulating these exact external loads so you can build up specific muscle groups safely and effectively.
But here's the thing. Strength isn't just one single monolithic concept. It completely changes based on what the activity actually demands. So you have maximum strength. This is your classic weightlifter, generating force with 100% effort to tackle maximum resistance in a single explosive contraction. Bam! On the flip side, you've got strength endurance. This is what a cross-country hill runner uses. They might only need, say, 50 to 60% of their maximum effort, but they have to overcome that resistance repeatedly for a much longer duration, constantly fighting through physical fatigue. 2 entirely different applications of muscular force, right?
Okay, Section 3, the science of strength. Let's look at the muscles and motor units.
Now, what's really interesting about this slide is how it breaks down athletic destiny. Your muscles are made up of 2 distinct types of fibers, and the ratio of these fibers in your body is a huge deal. You've got fast twitch fibers, which are white. These contract incredibly fast and generate massive force using anaerobic pathways. They are literally built for explosive power, like a 100-meter sprint. Then you have slow twitch fibers. These are red, they contract much slower and generate less force, but they are incredibly efficient at using oxygen aerobically. That makes them absolutely perfect for the long haul of distance endurance.
But it goes way beyond just fiber types. Actually, liberating that force from a muscle requires this perfect biological storm. Neurologically, it depends on the number and size of the motor units you recruit, and the sheer intensity of the nerve impulse firing from your brain. Physically, it relies on the cross-sectional size of the muscle because, bigger muscles do generate more force, and the chemical energy supply from ATP and creatine phosphate stored in your body. But please, do not overlook the mind here. Psychological factors like anger, aggression, or just intense motivation play a literal biological role. They push the brain to send stronger nerve impulses, recruiting more motor units to generate sudden massive force. It's fascinating.
Section 4, Understanding Endurance. Welcome to the battle against fatigue.
I really want to anchor us to this definition, specifically the phrase, under the condition of fatigue. Look, anyone can run fast for 10 seconds. That's easy. But endurance? Endurance is your body and mind's ability to maintain the desired quality of movement when absolutely everything inside you is screaming to stop. It's the invisible engine that keeps you moving when your muscles are toasted and your energy stores are running on empty.
To really grasp endurance, you have to understand how we use oxygen. Aerobic capacity is your muscles' ability to utilize a maximum amount of oxygen while working for long durations. Think of a marathon runner constantly transporting oxygen to their working muscles. Anaerobic capacity, on the other hand, is your ability to work with far less oxygen for short, intense, lung-burning bursts, like a sprinter. Both are totally vital, but they fuel the human machine in completely different ways.
Section 5. Let's talk about training endurance and actually building that capacity.
Let's move to and see how this builds practically. Athletes build capacity through what's called the continuous method. They don't just go out and run aimlessly. There's a strict progression. They usually start with a slow pace to build that baseline aerobic capacity. Then they bump it up to a fast pace to push their anaerobic limits. Next, they introduce changing paces. And finally, they might use the fartlek method. It's a Swedish term meaning speed play, where the athlete continuously changes their pace and duration on the fly entirely based on how they feel. It's an incredibly effective, dynamic way for seasoned athletes to train both their aerobic and anaerobic systems at the exact same time.
Another massive tool for building endurance is breaking the work into chunks. Let's contrast two highly effective methods here. The interval method involves working at a sub-maximum intensity, but, and this is the kicker, with an incomplete recovery period in between sets. Your heart rate dictates the load, and you start the next interval before you're fully rested. It's brutal. The repetition method is entirely different. Here, you're training near or even above your actual competition pace, but you get a complete recovery interval between sets. So one builds raw endurance capacity through sheer exhaustion, while the other builds pace judgment and anaerobic power through high-intensity execution.
Section 6. Flexibility and body composition, the final pillars of our fitness anatomy.
So these are the final two pieces of the health-related fitness puzzle. Flexibility is simply your ability to move body parts to their maximum range around a joint. This can be active, meaning done under your own muscular power, or passive, which is done with external help, like a partner stretching you out. It is absolutely critical for performance and preventing injuries. Body composition, meanwhile, is how we classify the body into fat weight versus lean body weight. It's a vital, baseline metric for understanding your overall health and how physically efficient you are.
And how do we actually accurately measure that composition? Well, clinically, we look at two main methods. The direct method is incredibly precise, but honestly pretty complex. It uses hydrostatic or underwater weighing to determine your overall body density. The indirect method is way more common and accessible. That involves a trained professional using a skin-fold caliper to literally pinch and assess body fat percentages at very specific sites on your body.
Which brings us to the ultimate question for you. We've explored the textbook science of muscular strength, the brutal biology of endurance, the role of those fast and slow muscle fibers, and the undeniable importance of flexibility and body composition. You now know exactly how the machinery works under the hood. So based on these 5 pillars, how are you going to take this knowledge and redesign your own training routine to build a truly balanced, high-performing body? Seriously, think about that next time you step into the gym or lace up for a run. Thanks for joining me on this explainer, and keep learning.